here's an example where we want to find, without a calculator, all solutions. Tangent x equals negative root 3 on the interval 0 to 2 pi. Okay, so how do we do that? Well, I've got some notes for you that I'm sending you. Let me rewrite the question here. So what do we have? Notice we just have one trig function, and it's just tangent. Let me go back to the notes and show you. Here's the notes I'm sending you, solving trig equations. So if you have only one type of trig function, which we do, and it's first power only, which it is, then just get it alone. And then take it to the unit circle and get two answers usually. All right, so let's do it. So it's already alone. So that just means we just need to go to the unit circle and find where tangent is minus square root of 3. Now remember, tangent is sine over cosine, isn't it? So here's the unit circle. Let me erase what I did previously. So I need to find out where tangent is minus root 3. Well, how do you do tangent? Remember, as we go around the unit circle, it's cosine sine, cosine sine, cosine sine, cosine sine. So how about so tangent is going to be sine over cosine. So in this case, it'll be 0 over 1 or 0. Tangent at this spot will be, again, sine over cosine, so it's a half over root 3 over 2, so, and then you flip that up, so that's a half times 2 over root 3. These cancel, it's 1 over root 3. Here, tangent, sine over cosine is going to be root 2 over 2 over the same thing, so it's just 1. Now, let's start being a little wise. Well, let's do one more. Well, yeah, let's be a little wiser about this. Where's tangent going to be negative? Remember what we learned about the signs. All students take calculus. That's where the trig functions are positive. So we're looking for where tangent is negative. Negative. So where's tangent negative? Tangent is positive. All are positive in the first quadrant, and tangent is positive in the third. In the second, sine is positive and his upside down cosecant, but the other four are negative, so tangent would be negative in the second. And in the fourth, cosine and his upside down secant are positive. The other four are negative, so tangent would be negative there as well. So we know we're looking for two answers in the second and fourth quadrants. So let's find tangent at the various points in the second and fourth quadrant. What's tangent going to be right here? Again, cosine sine, cosine sine, cosine sine, cosine sine. It's going to be sine over cosine. It's going to be root 3 over 2 over minus a half. Flip this up. Remember fractions dividing fractions. You're going to get root 3 over 2 times minus 2 over 1. 2's cancel. Negative root 3. Hey, there it is. That's what we wanted, right? Negative root 3. Yep, so there's one of the spots, negative root 3 right there. And it turns out, I just want to save time, if you fiddle around with all these, I believe you'll find, what is it? It's going to be, well, now I'm a little confused, honestly. It's going to be, it's always, pi, it's always 180 degrees. So if you look at the other side of this straight line, let me make that a straight line. You'll find it's right there. It's always 180 degrees away. It's going to be this spot right here. Tangent is sine over cosine. This is cosine sine, right? Negative root 3 over 2 over a half. Flip it up. So that's negative root 3 over 2 times 2 over 1. See, there it is, negative root 3. So it's this spot and this spot, 2 pi over 3. And I can't read that now. Let me see, 5 pi over 3. Okay, 2 pi over 3 and 5 pi over 3. Those two spots, tangent is negative root 3 and negative root 3. So don't confuse this with the inverse trig functions. Notice this is regular tangent. This is not tangent inverse. So you don't have to worry about the limiting to two quadrants thing. We don't do that. We take it anywhere it comes. So tangent is negative root 3 at 2 pi over 3 and at 5 pi over 3. We take both those answers, 2 pi over 3, comma, 5 pi over 3. They're both, and that's a messy answer, they're both valid answers. So we find the two spots from the unit circle for tangent.